Hi everyone, welcome to my YouTube channel, Zenith GATE Mechanical. So in the today's session, I will talk about what are the questions which came into the GATE 2025 Mechanical from the manufacturing technology. So the first question is, this question came from the casting chapter. The ratio of solidification time of a cube and the cylindrical casting you have to find out when the cylindrical casting height and the diameter are equal. So this is the condition given when the height of the cylindrical casting as well as the diameter are equal. And it is also mentioned the volume of casting are same. That means volume of cube casting as well as the volume of cylindrical casting are same. So you have to calculate the ratio of solidification time for cube to the cylindrical casting. Okay. So first of all, you have to understood how you will calculate the solidification time. So the solidification time you can calculate by using this relation K into V by A square, where V is the volume of casting and A will be the surface area of casting. Okay. So, but you have to calculate the ratio of solidification time of cube to the cylindrical casting. So, can I write the solidification time for cube to the solidification time for cylindrical or cylinder is equal to the volume by area ratio to the power of 2 for a cube divided by volume by area square for a cylinder, where K is the solidification constant. So this will be same for both the condition. Now, one more condition is given, the volume of casting are same. That means this volume and this volume will be cancelled out. So I will get one ratio of this solidification time for cube to the solidification time of cylinder is nothing but area of cylinder to the area of cube to the power of 2. Okay, now, so volume of casting are same means you just equate the volume of cylinder as well as the cube. That means the volume of cylinder is equal to volume of cube, which is given in the question. So volume of cylinder means pi r square h, and this volume of cube is a cube. And it is also mentioned h is equal to d. That means the height of cylinder is equal to the diameter of cylinder. So can I write h is equal to 2r? This is for cylinder. Okay, so the h is equal to 2r is given. So I will put this value here, 2r a cube. So that means r cube 1 by 2 pi into a cube. So from here, I will get the relation between the r and a. So the r value is nothing but 1 by 2 pi to the power of 1 by 3 into a. So this value, if you calculate, you will get 0.54 into a. Okay, so you got the relation between r and a. Now, if you again come to the first equation, which is nothing but the ratio of solidification time of cube to the cylinder. Now I got the relation between R and A, 0.54 times of A is equal to R. So from the first equation, the solidification time of cube to the solidification of cylinder is nothing but area of cylinder divided by area of cube to the power of 2. So the solidification time of cube, solidification time of cylinder is nothing but area of cylinder by area of cube whole square. So let us suppose this is the cube having side A, and this is the cylinder whose radius is r and the height is h. So what will be the surface area of cylinder? Surface area of cylinder is 2 times of pi r square. That means this top and bottom. And one will be the curved surface area. That means 2 pi r into h. And what is the area of cube? 6 times of a square. So this will equal to 6 pi r square divided by 6a square. So you just put the value of h is equal to 2r here. So this will become 4 pi r square. And this is 2 pi r square, which is nothing but 6 pi r square. So the solidification time of cube to the solidification time of cylinder is nothing but pi r square divided by a square to the power of 2. So you can put the value of r in terms of a here, so that a square will cancel out. So you will get the numerical value. So pi 0.54 into a square divided by a square. So once you will solve, then you will get the value of 0.84. Okay, so 0.84 will be the correct answer for this question. So you have to calculate this ratio of solidification time of cube to the cylindrical casting. So the correct answer is 0.84. This question is related to the rolling. The thickness of sheet is 30 mm and feed into the two roller. We get 27 mm thickness in a single pass. The diameter of roller is given as 500 mm and the process is feasible or not, that you have to find out, and the maximum draft can be represented. That means you have to calculate what will be the maximum draft in this particular question and is the process is feasible or not. And the coefficient of friction which is given as 0.12. Okay, so the four options are given. Now try to understand what is the happening in this particular question. There are the two roller. Let us suppose these are the two roller. Okay, so in between these two roller, one sheet is allowed to pass. And what is happening? Initial thickness, if you see, it is given as 30 mm. And when it is passes in between the two roller, the thickness is reduced to some particular value. Okay, let us suppose the thickness H final. Okay, so this is the H naught or H naught, I can say. So this thickness of sheet metal is reduced when it is passes through these two roller, which is rotating with certain angular velocity. Okay. Now, first of all, what is the maximum draft can be possible in a single pass, which can be calculated as mu square into draft is nothing but H naught minus H minimum, which is nothing but equal to mu square into R. Okay, so that means the minimum thickness of sheet metal which you can drawn if you are passing in between these two rollers. So, but the maximum draft you can easily calculate because mu value which is given as 0.12 and the diameter of roller is given as 500. Okay, so this is 0.12 square. Diameter is 500 means the radius will be 250. So once you will solve, then you will get 3.6 mm. That means the maximum draft possible in a single pass operation is 3.6 mm. 3.6 mm. So this process is feasible and the maximum draft you have to calculate, which is nothing but 3.6, and the process is feasible. So the option A will be the correct answer. So choice A is the correct answer. Wire drawing operation is performed on a perfectly plastic metal without strain hardening, assuming no friction and no redundant work. The maximum possible percentage reduction in a single pass. So first of all, the percentage reduction is nothing but the original area minus final area divided by original area into 100. Into 100. Original area means, let us suppose there will be a tube, okay, which is passing through this particular a small gap. You are applying some tensile force. Now this diameter will get reduced. That means, let us suppose the original diameter is d naught. Now its final diameter is df. So similarly, the area will be a naught and the final area will be af. So how much reduction will be possible? A naught minus af divided by a naught. So because I am talking about the percentage reduction. Okay. So the drawing stress relation is, the drawing stress is equal to yield stress into ln of a naught by af. ln of a naught by af. But for perfectly plastic material, because it is mentioned for perfectly plastic metal without strain hardening. So for perfectly plastic metal, the drawing stress will be equal to the yield stress. The drawing stress will be equal to the yield stress. So if you put this value here, then you will get the relation between the A naught and AF. Once you know the relation between A naught and AF, once you will put in the percentage reduction, then you will get the answer. Okay, so let us suppose this is the first equation. So yield stress is equal to yield stress ln of A naught by AF. This will be cancelled out. So can I write A naught by AF, which is equal to e to the power of 1, because this is the base e only. Okay, so e to the power of 1. Okay, so can I write AF by A naught is equal to 1 by E? So if I subtract this AF by A naught from 1, that means 1 minus AF by A naught is equal to 1 minus 1 by E. Okay, so you can write A naught minus AF divided by A naught is nothing but E minus 1 divided by E. That means E value is 2.732 minus 1 divided by 2.732. 2.732. So you will get the value around 0.6321. So in percentage, how much? You just multiply with 100. So 63.2 percentage. 63.2 percentage. The option B, which is correctly matching with our answer. So the correct answer for this question is option B. Option B. So in case of wire drawing operation for a perfectly plastic metal, the maximum reduction possible is 63.2 percentage.